Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to talk a little bit about the beginning of how we're going to go about finding roots of some higher order polynomials. So I think in the beginning of the year I definitely talked about how there's like three really important topics in Algebra 2. One of them we've already seen, which is like the function transformation stuff. And just kind of like visualizing how, different things affect a function. And then finding roots of higher order polynomials, which is what we're getting into right now. And then there's this really important trig stuff down the road. So this is actually a really famous theorem. And anytime you see the word fundamental theorem in math, it means it's really important. And it's got a really basic kind of premise here. It says, a polynomial of degree n is going to have n roots, okay? So I've always liked this meme. I thought this is funny. So a lot of times students will say, if I have x squared equals 9, then x is 3. And it's really wrong because in math, we don't just want a answer. We would want anything that solves a problem. And in this case, right, 3 works definitely, but also negative 3 squared is 9, right? And so Yoda is saying there is another. But this is a very simple statement to state, but actually it's really hard to prove. And this is from a textbook that I took a math class out of years ago. This is what a lot of math eventually looks like, not to try to scare you, but just to show you what it really looks like. It's a hard class, but so to prove this, you would need to understand what all of this is. But in this class, we're just going to kind of take it for granted. So I just need you to know that basically any, polynomial I have better have n roots. And one of the things that we're going to do first is start kind of working with that idea. So given this one, right, so we have an x cubed. And since it's a cubic, we know right off the bat there's going to have to be 3 roots, okay? And a little hard to read, but this says, very important result in math. This is just what I was sort of saying. I just wrote it down right here. So the number of roots will always equal the highest exponent. And you may have to include repetition. Like you might get, even here's a silly little example. If you have x cubed equals y, the roots of that thing, if you set it equals 0, you really can kind of think of it as like factoring it as x times x, and each one of these gives you a 0. But those really are the 3 roots for x cubed. And so you might have to allow that. You might have to allow repetition. And you might you're going to see complex roots. So the first way that we find roots in this class is basically if I give you one, you need to simplify this using that root and get the other 2. And the way you should be thinking to do that is the synthetic division thing. So if I set up this table, all right, bring this down, right, you're just going to multiply and add. So I'm multiplying here, put that number there, add. Multiply now here and here, put that number here, add, so on. So I get negative 5, and then I add, and I get 2, and then negative 10, and then I add, and I get 10, and then negative 50, and I get 0. And that is the remainder, right? Which, if negative 5 is a root, you should be dividing in perfectly, right? You shouldn't have anything left over. So that means we have now our quadratic, x squared plus 2x plus 10. And this thing, it kind of looks like you might be able to factor it, do like a 5 and 2 thing, but it really doesn't work out because of the plus 2 and plus 10. So you just have to do quadratic formula. So negative 2 plus or minus b squared minus 4ac, and then all over 2a. And then this in here is negative 36. And so this one's fairly nice because you just get plus or minus 6i over 2, which, you can even go one step further now. You can get negative 1 plus 3i, or actually let's just do it no reason to do that. So we'll just do it like that, plus or minus 3i. And that's it. So you've got these two roots, and then you've got this root, right? So those are all 5 x-intercepts of this x cubed. And you know you're done finding any of the roots because of this thing. So that polynomial is x cubed, so it's going to have 3 roots. So you just stop when you get the same amount. All right. Just wanted to do one more. And this is hard to read again. I've got to stop using blue here. But when we solve higher order polynomials, we always just use the quadratic formula. Or I guess we could factor it down to like a linear term like I've got even here. So everything and the very end will reduce down to a problem we've already done. That's what I'm saying here. So it's just like when we did systems of equations, like system of 3, we just reduced it to a system of 2 and then solved that. This is the same thing. You're not going to ever use like, there actually is a cubic formula and there's actually a quartic formula, but we're not going to use those because everything that I'm going to give you, you can just boil it down and get it simplified to a quadratic or a linear term. So this thing right here is a 5th degree because if you multiply that, right, you get x to the 5th. So we need 5 roots. And right now, the only thing you can really do, you got this part in here, you could take an x squared out of that and get that. I'm just going to copy that term over. And then, honestly, you're good. You've got quadratic or linear terms, and that's what this is basically saying. Once you have that, you should be able to solve it. So you know there's x squared. You got a 0 and a 0 root, like repeated there. This thing has a root of plus or minus I, right? And this one has a root of 1. And so that's it. 1, 2, 3, 4, 5 roots. And that's just another example to show you that truly you will always get the same amount of roots as the highest exponent there, okay? And it is the highest exponent, not in a factor or something, but in the like fully multiplied out version.